you're cutting your parts, they're laser cut, they're pretty accurate, your parts seem pretty clean, right? So it seemed like a perfect company, perfect application. So do you guys have automation in your plant currently right now?
Besides the DDL and that, really?
Our lasers, we do have some automation, and then the other robotic welding cells we have.
Okay, so you have other robot cells in the plant currently right now welding up parts for it.
Correct. Just the two that we have beside us now, the ones that we're working at.
Yeah. So
Two Fanuc robots.
Two Fanuc robots and cells. Yeah.
Yep.
Talk a little bit about that. Have they been successful for you? Are you making money with them? Are you happy with them? Are you dissatisfied with them? Are there limitations to them?
Just running into limitations now. I would say with the amount of data that we have on them, it's pretty, for weld schedules, programs, the memory, I would say the versatility of it, being able to move it like we can with this one now. That kind of locks you down into the size of the parts you can for your small robot, your big robot, where you can do it at, stuff like that. But.
So you ran into memory issues in the sense of how many programs you can put in, weld schedules and everything. So you're bumping up against the limit of that. And then your footprint, I heard you say the size of for the given work envelope of the robot, the footprint size of the cell is large. Right.
Yep.
And then it's not really portable.
Right.
We changed programmers, so that's when Matt moved into his role as kind of learning the robotic programming. So we had the Fanuc software for that. It was really cumbersome.
The big problem is we can find people to program the robot, but they're not welders. So they can put points, but they don't know to push the angle of the torch.
Right.
And if I take a welder to put it in the weld cell we have now, the 2 weld cells, it takes them so long to learn the pendant. Software pendant. And I know welding. It's hard for me to touch it up because I don't know the pendant.
Right.
I can tell them where we have to move it and what we have to change.
Yes.
But I cannot do it physically myself.
Good. And the learning curve of coming up to speed on learning all of that, especially when they've been in for a while, so you're relying on them for production.
Yeah.
So when you get it new and it's been designed and it's coming in, you build into the ramp up curve, right? The startup period, the time for training and everything, right? So you're going to buy it, you're going to pay X amount of money for it. Then you're going to say, I'm going to designate these 2 people to be the programmers of it. And then you're going to send them for training. So, you can kind of coordinate all of that. But once it's up and running in your plant, and please correct me if I'm saying anything that doesn't align with your guys' experience or whatever, but once it's running in your plant, you're relying on it now from an operational standpoint for production, right? I've got parts that I need to make. So now if the programmer quits, goes work somewhere else, or he's on to something else, and now you're limited, to just say, okay, now I'm going to send somebody else, I'm going to lose production, that they're doing something else, right? They're hopefully producing for you. You're going to take them, send them to training, then they have to come back and they have to learn it, which means now you have to kind of shut it down in time for them to work on it, to get the skill set up. That's a major issue that I have had many experienced myself in many companies talking about.
It's huge because they also have the employee has a pull on you. They're that much more valuable.
Yes.
So if I go, you're either gonna have to pay me more, or you're gonna figure out how to hire somebody else to do it.
Right. We have size of footprint via work. We have portability and ability to move the cell around. We have programming language, the time it takes to get up to speed, and how many people you have in your shop floor to be able to do it. When it's running, does it work? Does it make parts for you? Make money?
Most definitely.
Oh yeah, it's our number 1 profit center in welding, obviously.
Yeah. Okay.
We'll put 50 parts on the robot, even if they're 5-minute runners.
Mm-hmm. Make the program for that part. Is that a significant amount of time? Are you talking half a day, or what's
a smaller part like that, you're talking. Well, by the time you make fixture in that, you're talking day to make a fixture, day to draw it up, then you got to cut it all and put it together. So you're talking another half a day there, or day, and then half a day to program.
Okay.
Sometimes, and then typically it's two guys, it's usually not bandwidthing together.
To get it done. But what's interesting is you guys make that investment to do that 50 parts, because in theory,
But
you
we have our
could weld them
history.
manually faster than,
Oh, most definitely.
But we have our history, right? So those 50 might be coming every month.
so that was where I was gonna go next.
That's
You
true.
must have repeated volume of it. You're doing
Yes.
50 at a time, but you're consistently doing
We
50 a
won't.
month.
So like that part, we would put hand weld for the first 3 months.
Yeah.
Okay, we're getting consistent every month. Let's take the time to build a fixture. This,
Fixture program.
so,
Yes.
and we're not gonna make our money till 5 times, we run 5 more
You
times.
work fine, right.
Then we'll start really
Get the
being ahead
investment
of what
back.
the
Yeah.
what the hand welders are.
You know, the other difference in that is the hand welders come and go, show up, don't show up. They have their people issues, right?
Right.
Once I have this program on the robot, I just gotta find someone to run it.
You guys didn't have those 50 part runs every month. To make the investment, in other words, to overcome those barriers, wouldn't be worth it. Like you said, you have to do 5 runs. In other words, it's 5 months before you have your ROI. You've got the return on investment that you put in putting it on there, before you're now making the profit of the difference between the manual and the robot
Correct.
on every run. And that's very interesting, because the goal of a cobalt welding system, and specifically higher BotX and the Ready Arc and Air Gap product and offering, is to lower the barriers of entry. In other words, it's not 5 months. Hopefully, you can tool apart and get it up and running, and you've got your ROI at a minimum in the first run, if not some profit off the first run.
Sure.
And then everything else after that,
It's all
Right.
cake, yeah.
it's all, it's paid. So then how does this product fit into that? So what I'd like to do is roll over into kind of a conversation that says, so you guys obviously were looking for some more automation. What was it, first of all, where did you hear about and get interested in cobalt welding, and then why BotX? Like, what made you call us up, and then, get conversations, and then decide to bring the BotX in?
Back to what Dan said earlier, I'm not a welder, I don't know weld settings. I'd love to come in and make the waypoints and have him come back and go, fix this, fix this, fix this. Now, he can do that, he's already learned it in a day. That's the beauty of it. And one of the bigger differences for me was your ease of programming.
And I have a hard time learning dependence and that. But right now, after a day of teaching this one where you can grab the actual robot, I'm 100% confident. And I can take a lot of my pictures I take off the shelf right now, put it on the table for a hand welder to use, and I can take that picture and put it on this table.
In terms of the BotX, right?
The BotX.
Yeah, so,
This is a no-brainer. Our guys here, I can teach our guys, and just by watching you guys 10 minutes, I would have been able to say, we can teach our guys how to program this. Let's get it in the shop. We have so many parts that are smaller that our guys tack up and weld. We could have a guy tacking it up, setting it on the table, it welding it for him. Basically, we're doing it twice as fast.
would it be fair to say, you view it as a bridge that's bridging between the want and the desire and the need, for a healthy, strong company that can employ people, and people can have confidence that it's gonna be around, it's gonna make money, meet the needs of the consumer out there, which is also very important.
Yeah.
And your ability to be able to say, I can take that technology that is supposed to answer that problem and really make it work in the real world of my shop, in a shop floor.
Correct.
That's true. Okay.
Correct.
Why?
I would have saw that it's mobile. I can push from booth to booth. So if I'm doing this part in booth 5 this week, next week I'm doing it in booth 2. I can push
Okay.
from that booth to that booth. And not have the guys have to switch around. Not only that, take my guys that are skilled welders already and be able to learn this thing within a day, to be able to touch up, not necessarily program it, but touch up a program, change the weld schedules, and have that thing in their booth welding and not taking the floor space up.
So simple and quick, it's hard to even explain, to compare it to the Teach Pendant. I mean, for me, other than the Teach Pendant, if I want to get close, I slow down to 5%, and I move my X, Y, and my Z. You're moving 3 different buttons to get down into the corner point that you need. Okay, so you're looking at 30 seconds, go down to 5%, move to the part that you need. Then you're saving that weld schedule, then you're backing it back out. right there, I can say that point with your robot in 5 seconds, and it's gonna take me a little over a minute to say that point with Beachman. That, yeah,
Problem on teach bend, it's gonna take you 5 minutes to find your spot.
that too, yeah, awesome.
Yeah, so if you look at the whole,
Yeah, the
in other words, there's the saving of the point going through the software side of it.
Yeah.
But there's also the whole getting the robot to the position in the right angle, all that stuff. Yeah, because you're already talking about doing some
Yeah.
sub-assemblies.
Yes.
Right, so welding up the sub-assemblies to reduce the cycle time of the traditional cell, and those sub-assemblies can then.
I think our current part, how many parts per day did we go to for doing that?
We went from 42 to, was it 59?
So that one that we just put on the BotX, that's
Yeah.
a perfect example of what just happened with that.
Yeah.
And that robot's out a month and a half with work.
Right.
So
You
that
have to wait a
matters.
month and a half.
That matters, so
do
you
that.
can take that month and a half now and bring it down a bit, and if you keep doing that.
Or I've got some gaps for some hot jobs that come in, right?
For example,
Yeah.
the hub, we did put that on our other robot.
Yeah.
To try to save time. Well, I had to make a fixture for it. That took me a while. And it took us half a day to program.
Mhm.
Get figured
Online,
out.
online
Offline.
programming, no, online, so you took the robot and
Yeah,
consumed it.
online fix.
So yes, the robot wasn't making production.
Yes.
Right.
Whereas
That's what
this,
you're getting at.
I could have rolled it in the booth, used my tack fixture I have already. Within an hour, I would have been up and going. 'Cause I don't have to
Making
build,
part.
I don't have to build a fixture for it either.
Let's talk about that hub part that you guys did, okay? So you have this hub part that you guys are doing, it was a circle. How long did it take you to fixture that on the table?
About half day.
No, on the new.
Oh, new table.
On the bottom,
On
yeah.
Yeah.
5 minutes.
Under 5 minutes.
Under 5 minutes.
But you said you took, how long to make a fixture for the traditional?
About half a day.
Half a day, right? So I don't care if it's 15 seconds or 5
That
minutes,
was the
the
job.
estimation of 5 minutes, because quite frankly, I'm comparing it to half a day. So 15 seconds or 5 minutes compared to half a day, it's like, we're still winning. Okay, I'm still in the winner's circle, that's all I
Well,
care
not only
about.
that, you didn't count the material we had to cut for making the fixture.
For making a fixture, right? So this flexible tooling system is to tool it, and then how long did it take you to put the program in? Not the weld development, but just put the circle in?
I was gone for 5 minutes, about 10.
A 10 to actually make the, go with your high estimation, 10 minutes to put the circle in, and then what we did weld development for, 30 minutes? We welded 4 or 5 parts
Yeah.
before we had something that was, you were like, this is acceptable.
From 10 to 10:30 is what the time was, from start to finish.
From start to finish, right? And you had basically a production ready program.
Yeah.
Ready to go, you could run off your 1,000 hubs that you had.
Correct.
30 minutes.
Yep.
Again, I'm not gonna make the argument, because we're in the winter, we're solidly in the middle of the bullseye, right? Like, there's no, like, that's fine, you said an hour.
Well, that's why, like,
We're
the
still
P
there.
part, the P parts we were doing.
Yeah.
The guys, we used to have them on the robot, but we got so busy on it. Now our guys can handle them.
That's a thing we see a lot.
The one that you did the stitch weld on one side.
Yeah.
You start
Well,
with-
I just got another order of 150.
150.
So now
That's
what's
something I
happening-
can push by that booth, say, hey, I want you to tack it, you just weld 2 ends,
Yeah.
and I'll just come and put a weld down each side.
Or even if that.
You know how long that would take? Nothing for me to
No.
program.
Yeah.
Not only that, that's something the guy in the booth can figure out. I can say, hey,
What's happened is
so now I can bring this thing to the booth, not lose any real estate at floor, and still have the guy, have him on a robot.
You can get to any 6 of them welders and not have to designate it to one guy.